In this lesson, we're going to be discussing arithmetic operators. The lesson objectives: acquire the basics of arithmetic operators, and that includes addition, subtraction, multiplication, division, and modulus. So let's start off with addition. The addition operator is used to add integers or doubles together, and we use the plus sign as the addition operator. Our examples include both integer and double examples. So integer x is equal to 3 plus 5. 3 plus 5 is equal to 8, so 8 gets stored into the integer x. Make sure that when you're adding integers together, or rather when you're storing a variable or value into integer x, that you're only using integers for when you're operating. So what that means is make sure that none of these are doubles. None of these have decimal points. Don't even think about putting a decimal point if you have an integer as your declaration, because the computer is going to immediately give an error. Even if it's 3.0 plus 5.0, it's still going to give us an error because you are trying to add doubles together and then store that double answer into an integer, which doesn't work. Double y is equal to 3.5 plus 4. Even though that you can't use doubles in integers, you can use integers in the double, because what happens is that the computer is going to upgrade all the integers to doubles. So 4 actually becomes 4.0. 4.0 plus 3.5 is equal to 7.5. Therefore, 7.5 gets stored into y. The subtraction operator allows us to subtract numbers in Java, and we utilize the dash sign or the subtraction sign, if you may, to pursue that. Examples include integer w is equal to 5 minus 3. 5 minus 3 is equal to 2. Therefore, 2 gets stored into w. Again, make sure that when you're storing something into an integer, that it should only be integers that you're using. Double a is equal to 3.14. Subtract 0.14. That should return 3.0. Because you're subtracting 0.14 from 3.14, the 0.14 cancels out and you get a 3.0. The multiplication operator allows us to do multiplication in Java, and we use the asterisk sign. So examples: integer nice is equal to 42 times 10. 42 times 10 would end that with a semicolon. 42 times 10 is equal to 420. Therefore, 420 gets stored into nice. Double whack is equal to 34.5 times 2. And 34.5 times 2 is equal to 69.0. 69 does not get stored into whack. 69.0 gets stored into whack. And the reason why is because 69.0 is a double. 69, just 69, is an integer. So make sure that you know that. Now, division is a little bit weird, so bear with me. So the division operator allows us to divide two numbers together, and we utilize the slash in order to pursue that. Examples: integer a is equal to 8 divided by 4. 8 divided by 4 should return 2. So double b is equal to 9 divided by 4. We know from our math class that 9 divided by 4 is probably going to give us some decimal number, because 4 fits into 9 two times and there's still a remainder. So technically speaking, it should be more than 2. However, the compiler returns 2, and the reason why is because we're only using integers to divide. So the computer is like, all right, I want to store integers. I'm dividing integers. The person probably wants a integer as the answer. So it returns 2, and then 2.0 gets stored into double b, not 2.25, because, well, as I told you, these are not doubles, these are integers. So to conquer that error, you put double C, you put 9.0 or 4.0 if you want to. 9.0 divided by 4.0. What the compiler does then is like it upgrades all the other numbers that are not doubles into doubles. So it sees a double, it's like, all right, the guy probably wants a double as my answer. So we're like, all right, 9.0 divided by 4.0, right? Because it upgrades that integer to a double and it returns 2.25. The modulus is the remainder operator and returns the remainder of two numbers after they've been divided. And we use the percentage sign as the modulus or remainder operator. Examples include integer g is equal to 10 modulus 3. 3 fits into 10 3 times. So 3 times 3 is 9, and we subtract 9 from 10 and we should get 1. 1 is the remainder when we do 10 modulus 3. Double h is equal to 5 modulus 6. 6 does not fit into 5 any amount of times. Technically speaking, we could say 6 fits into 5 0 times. Therefore, 5 becomes the remainder. And since we're storing it as a double, it becomes 5.0. Alright, so let's code. I'm in the compiler right now, and let's start off with the addition operator. Integer x is equal to 5 plus 3. And then we print out x. So let's do some basic math. 5 plus 3 is equal to 8. 8 gets stored into x, so therefore when we print out variable x, it should print out 8. And it prints out 8. Make sure that you do not put a decimal inside this, because I know that this will probably equal some type of integer, right? But the computer gets an error, or gets an error because we get incompatible types, possible lossy conversion. So it sees two doubles and it sees that we're declaring an integer, so it doesn't do that because we're probably going to lose some data. So make sure to not have decimal points when you're utilizing doubles. When you're utilizing integers. However, when we print out double x is equal to 5.4 plus 3, we should get a double, 8.4. Even if we have both integers, it should compile and print out to 8.0 because we're not really going through a lossy conversion. A double is just a more advanced version of integer. So every integer can technically be made into a double, but not every double can be made into an integer without losing some data. If that doesn't make sense, let me give you an example, right? For an integer to become a double, it simply just has to add 0.0 at the end. So 5 becomes 5.0. That's the exact same thing. 6 becomes 6.0, 7 becomes 7.0. But when we try to convert a double into an integer, right, we might lose some data. So 7.5 might become 7. We just lost a 0.5, so that is a lossy conversion. We're losing some data. So that's why we can use integers when we're utilizing arithmetic operators and storing into a double, but we can't do the opposite when we're doing integers. Alrighty, so now let's use the subtraction operator. Integer x is equal to 3 minus 5. 3 minus 5 is equal to negative 2. Negative 2 gets stored into integer x. So when we print x out, we should get negative 2. Similarly, we can use doubles when we are declaring a double. Let me change the declaration into a double and run it. And we should get negative 2.2 because 4.2 subtract 6.4 is equal to negative 2.2. Alright, now let's do the multiplication operator. Integer x is equal to 6 times 5. 6 times 5 is equal to 30. 30 gets stored into integer x, and then when we print out x, we should get 30. And we get 30. Now with the double, I want to try something different. So let's say we have a diameter. So double diameter is equal to, let's say 10. All right, let's say our diameter is 10. And the value, or the way that we can calculate for the circumference from your math class, we know that circumference, I hope I spelled that right, we know that circumference is equal to pi times diameter. So what we can do is, since we have our diameter, now what we can do is find the circumference. Now, I'm not going to actually write out the entire pi because pi is irrational, right? It's never ending. So we can just use a basic approximation. Well, 3.14159, and then we can access the diameter, and then we can print out the circumference. Compile. And as you can see, it gives us our circumference. So if let's say a circle has a diameter of 10 inches, then the circumference will be 31.4159. Alrighty, so now let's do division. Again, division is a little bit weird because you might accidentally return an integer instead of a double, but let's work through it. So the basic for one is integer x is equal to 8 divided by 4. So 8 divided by 4 is 2. So when we print out integer x, we should get 2. I put 2 by accident there. And we do. So now let's try, I'm going to save this for later. That's how you make a comment, if you recall. Double x is equal to 9 divided by 4. Like I said before, we know from our basic math class that 9 divided by 4 should give us a decimal number. But when we print it out, what happens? We get 2.0. We know that's incorrect because, well, 9 divided by 4 does not fit into 9 an exact amount of times. It's a decimal number. So technically speaking, this will not give me an error. And the reason why is because the compiler sees 2 integers and it's like, all right, I see 2 integers, I'm going to return an integer. So the way we can conquer that is by making one of them a double. And when we make one of them a double, right, then the compiler upgrades all the other ones to a double. So 9.0 is now a double, right? The compiler automatically makes 4.0 a double and then returns a double and stores a double, the actual double answer, into our variable x. And there you go. We actually get 2.25. Our last one is the modulus operator. Integer x is equal to 27 modulus 5. So 5 fits into 27 5 times. 5 times 5 is 25. And 25, when we subtract that from 27, we get 2 as our remainder. So when we print out x, we should get 2. Again, I tried to put 2 in the print statement by accident. And we get 2. Similarly, if we just change it into a double, instead of returning 2, what will happen is that it will return 2.0 because 27 modulus 5 returns 2. And then since we want to store a double instead of an integer, 2 is an integer, so it upgrades it and it becomes 2.0. We can also similarly just use 28.5 and 3.5. That makes sense. The reason why I am picking this out of the top of my head is because 28 shares, well, 28 divided by 7 gives us an integer. So 3.5 is actually half of 7. So 28 actually has an integer amount, but you'll see. So we get 0.5. And the reason why is because the 3.5 should fit into 28 approximately 8 times, because, well, 3.5 times 2 is 7, and 7 times 4 is equal to 28. So we get 3.5 modulus 28.5, and it should fit into 28.5 approximately 8 times, and 0.5 is our modulus. That's a lot of math. Luckily, the computer is doing that for us. And that wraps up our video on arithmetic operators, and I hope you enjoyed it.